Take a look at these. Notice it says solve for x here, which means I've got options. All right, I can either solve by factoring if that's possible. I can use completing the square, or I can use my quadratic formula. All right, always check for factoring first. And really, if we look at this first one, the first thing we need is for this thing to be set equal to 0. And we need that to even check to see if we can factor. So I'm going to subtract the 9x. So I get 3x squared minus 9x equals 0. And now I'm going to solve, and this one can be factored. I can factor out a 3x. So if I put the 3x on the outside, that would leave me with an x minus 3. And I've got two factors. I just set each factor equal to 0. I do the 3x equals 0, and I do the x minus 3. Give myself a little bit of space here. The x minus 3 equals 0. And I solve each. This one I divide by 3. I find out that x equals 0. This one I add 3. I find out that x equals 3. Okay, so my two solutions for this one are a 0 and a 3. And that's it. If I look at the next one, I start off the same way. It's already set equal to 0. I want to check to see if a factor. Since I take trinomial, I build a bridge. So I build a bridge that gives me a 6. And when I think about this, two numbers that multiply together give me 6, but add together give me 4, it's not going to happen. There are no two such numbers. So this one I either have to do completing the square, or I have to use my quadratic formula. I would only use completing the square if the leading coefficient is a 1 and the middle term is even. And if you notice, I have both of those conditions met. So I'm going to do completing the square. So I'm going to subtract the 6 to create space. So that's going to give me an x squared plus 4x with a little bit of space equals a negative 6. And now I complete the square. I take this middle term. Right here, I take this guy, I divide it by 2 and square it. So if I take the 4, divide it by 2 and square it, that's going to be 2 squared, which is 4. So I'm going to put a plus 4 here. Whatever I do to one side of the equation, I just put a plus 4 over there, I have to do to the other side of the equation. All right, and now I'm going to factor. And the reason I picked that specific value is because this factors into x plus 2 times x plus 2, which is x plus 2 squared. All right, I made it a perfect square, and now over here I've got the negative 2. And now to undo squaring something, I have to take the square root, so I take the square root of each side. So that's going to give me an x plus 2 equals plus or minus the square root of a negative 2. And now I just subtract the 2 from each side. So I get x equals a negative 2 plus or minus. Well, the square root of negative 2, whenever I have the square root of a negative, that's an imaginary number. I can take an I out, and the 2 is still trapped. So my final answer is actually x equals negative 2 plus or minus I root 2. And that's it. Okay? That's my answer. Keep in mind that that means two things. All right? Plus the plus version and the minus version. So I get two things there. And that's it. If I take a look at the next one, again, I'll always look for factoring first. In this one, this is difference of squares. Now, I'm going to factor a difference of squares. That's going to factor into conjugates. Remember, one's a plus, one's a minus. So it's x plus 8 and x minus 8. And I set each factor equals 0. X plus 8 equals 0. X minus 8 equals 0, and I solve each. I subtract 8 from each side. I get x equals a negative 8. Here, I add 8 to each side, so I find out that x equals a positive 8. And that's it. Okay, solving my factoring. Again, with the next one, I'm going to subtract that 3 from each side. So I'm going to subtract the 3, so that gives me x squared plus 4x minus 3. And I only do that to have it set equal to 0, so I can check for factoring. I build a bridge. That gives me a negative 3. Two numbers that multiply together give me a negative 3, but add together give me a positive 4. Well, it's not going to happen. All right, there are no two such numbers, so this one can't be solved by factoring. So what I'm going to end up doing, again, I've got a positive 1 here and an even number here, so I'm going to solve by completing the square, which means I want to move this constant term. I'm going to add the 3 to each side. All right, but keep in mind, that's going to bring me back to my original problem. All right, it brings me back to this guy. When I add that 3 to each side, I get this. Okay, I couldn't factor it, so now I'm going to complete the square. And again, I do the same thing I did before, b divided by 2 and square it. So that's 4 divided by 2 and square it. That's 2 squared, which is 4. So I put a plus 4 here. Whatever I do to one side, I have to do to the other side. And now this is going to factor into x plus 2 squared equals 7. I got to take the square root of each side, and I find out that x plus 2 equals plus or minus, I probably need an equal sign in there somewhere, equals plus or minus the square root of 7, and now I'm going to subtract the 2 from each side. And when I do that, I find out that x equals negative 2 plus or minus the square root of 7. And that's it. All right, that is done. I can solve that by the quadratic formula, which will get me the same thing. I'll just have to do a little bit more reducing, that's all. If I take a look at the next one, again, this is already set equal to 0, so first thing I do is build a bridge. I want to see if this is going to factor first. So that's going to give me a negative 12. So the two magic numbers here are going to be a negative 4 and a positive 3. So since I can come up with those, it means I can factor this. Now, since there's a 2 out front, I can't use my shortcut, so I'm going to have to split up the middle term and do factoring by grouping. So I split up the middle term, so that's going to be 2x squared minus 4x plus 3x minus 6 equals 0. And I factor by grouping. I group the first two together, group the second two together. Out of the first two, I can take out a 2x, which leaves me with an x minus 2. Out of the second two, I can take out a 3, which leaves me with an x minus 2. And this is where magic happens. If I look, I've got an x minus 2 twice. That means my two factors, if I pull that guy out, x minus 2 is one of my factors. The other factor is the 2x plus 3. So what's left when I take away the x minus 2? And now I set each factor equal to 0. X minus 2 equals 0. And then the 2x plus 3 equals 0. And I solve each. This one I add the 2 to each side. I get x equals 2. This one I subtract the 3 from each side, so you get x equals a negative 3, and then divide by the 2. I'll just show that real quickly off to the side. So I get a negative 3/2. And that's it. Okay? But again, solving my factoring is always the easiest method, then go to completing the square or the quadratic formula. If you use your quadratic formula in any one of these, it's still going to work. This last one, I've got 2x squared plus x minus 5 equals 0. Again, it's already equals 0. I build a bridge. X is going to give me a negative 10. And now I'm sad because there's no two numbers that multiply to give me a negative 10, but add together to give me a positive 1. So I can't factor this, so I either have to go to completing the square or my quadratic formula. And if I look, I don't have a 1 here, and I don't have an even number here. So this is not a good candidate for completing the square. So I'm going to use my quadratic formula. Finally, Mr. Jansen, I've been waiting all day to use this quadratic formula. So x equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. And I just start plugging away here. The opposite of b is a negative 1 plus or minus the square root of b squared, that's 1 squared, minus 4 times a, which is 2, a, which is 2, times c, which is a negative 5, all over 2 times a, which is the 2. And now I just simplify. It's negative 1 plus or minus the square root of 1. This is going to be plus 40. Okay, and be careful with your signs there. All over 4. And that's going to give me a negative 1 plus or minus the square root of 41 over 4. And since I can't simplify that square root and I can't do any division here, I'm just going to leave my answer like that. Okay, that's it. Okay, those are my two answers. If you split it up like this, that is also fine. That is perfectly acceptable. But again, you can just leave it the way it was. Okay? If I take a look at this one, completing the square. When we're completing the square, remember, this one we're just completing the square and factoring it. And again, we want to leave it as fractions. Okay, make sure you're leaving it as a fraction. If I look at this guy, I just take the b value, I divide it by 2 and square it. So I'm going to take the negative 12, divide it by 2, and square it. And that's going to be a negative 6 squared, which is 36. So it's a plus 36. And now this factors into x minus 6 squared. And again, remember the shortcut is that it's what's in the parentheses there. All right, it's the minus 6. I do the same thing with this guy. Negative 7 divided by 2 and square it. And to square something like this, I just square the numerator, then square the denominator. Negative 7 squared is a positive 49. 2 squared is 4, so it's a plus 49 over 4. And now I factor it. Again, the shortcut here, it's x minus 7/2 squared. And that's negative 7/2. It was what was in the parentheses. And that's it. All right? So I filled in the blank and I factored it. I filled in the blank and I factored it. And that's all you have to do. For these, it says to list the number and type of solutions. Remember, if we just want the number and type of solutions, all we have to do here is find the discriminant. Remember, the discriminant is this guy. It's the b squared minus 4ac. All right, it's the thing under our square root in our quadratic formula. And I just have to find the discriminant. So that's b squared. So that's 6 squared minus 4 times a, which is 1, times c, which is 8. So that's going to be 36 minus 32, which is a positive 4. If my discriminant is a positive 4, and think about this really, it's the piece of the quadratic formula that's under the square. It's plus or minus that guy. If this number right here is a positive 4, the square root of that is 2. If I'm adding or subtracting a 2 from a value, it's going to give me 2 rational solutions. Because I'm adding a 2, I get a rational solution. I'm subtracting 2, I get 2 rational solutions because it's the perfect square. So this is just 2 rational. And that's it. All right? And it's easy to think about logically what comes out of there. Okay, what kind of a number pops out of the square root? Is it rational, irrational? Is it complex? All right, is it imaginary? Number 12, I do the same thing. I do find the discriminant, so the opposite of b squared. I almost went to do my whole quadratic formula like a crazy person. Negative 4 squared minus 4 times a, which is 1, times c, which is 4. So that's 16 minus 16, which is 0. So now I've got a 0. And again, what does that mean? If I've got plus or minus the square root of 0, well, that means I'm adding or subtracting nothing, which means my only solution, this whole thing's going to go away. My only solution is the opposite of b over 2a, which means I'm only left with one solution. And it's a solution that's being expressed as a fraction. So if it's being expressed as a fraction, that means it's a rational solution. So it's one rational solution. It's one rational. And this is all it's asking for. And if I take a look at this last one again, b squared. So let's see, 3 squared minus 4 times a, which is 1, times c, which is 5. That's 9 minus 20, which is about a negative 11 or so. And if I've got a negative 11 here, well, that means I've got the square root plus or minus the square root of a negative 11. That'd be like plus or minus I root 11. If I've got imaginary numbers, it doesn't matter what the rest of this is. If I add an imaginary number, it gives me a complex solution. If I subtract an imaginary number, it gives me a complex solution. So I get 2 complex solutions. Okay? And the only one we're missing right now is the case where you get 2 irrational solutions. And 2 irrational solutions happens when we get a positive that's not a perfect square. Let's say the discriminant was a 13. Okay? If I take the square root of 13, it's going to give me a never-ending decimal. This is an irrational number. And if I add an irrational number, my answer is going to be irrational. If I subtract an irrational number, so the plus or minus gives me 2 solutions, and it would be 2 irrational for that case. That's the one that's not present here. Okay?